Thank you. Whoa, Web API Day. It's a whole day just for Web APIs. It's like my most awesome day. It's great. Hello, everybody. My name's Ruth. As Matthias said, my name's Ruth. This is the sort of part of the talk where everybody introduces themselves and says why they should be here, who they work for, how long they've been doing it, why I should be here talking to you about web audio, what's my background. I've got a laptop. You can see it in this picture. Yeah. Thank you very much. Thank you. My job title, Street VJ. This is a projector pack that I made a while ago. I've got a little pocket projector, and I put it in a bag, and I kind of hacked it like it's an usherette tray, and it projects out the bottom. So I can basically carry it around the streets of my city, projecting onto things. And then I built a piece of software which actually runs in a browser, which I can control with a MIDI controller, and I actually mix these visuals. So that's what I do as a job. Quite like the round of applause. How long have I been doing this? How long is an audio reactive LED string? I've been doing it for around 15 years, actually. And clients that I work with, this is Bobby the dog. He's my favorite client. The only thing that he's ever tried to do is push me off a paddleboard into a stream of stingrays. Definitely qualified to be here to talk to you about the Web Audio API in detail. There's a couple of problems with talking to you about the Web Audio API in detail. First of all, it's a very, very big spec. It looks a little bit like this. This video was over 2.5 minutes long, and all I was doing was just scrolling down the spec before I sped it up. So this is super fast, right? And I've got to cover this in... No, that's okay. I've got 43 minutes left. I've got 43 minutes. But it is big, and there's a lot to it. And there's a lot of functionality, and there's quite a bit that you might not even understand or get how to get started with. So I'm hoping that I can cover that. If this is all a bit much for you, by the way, MDN docs, it's a little bit calmer. It's pretty good. It's still pretty heavy. I mean, this is just the homepage, and we sort of talk about where it starts, lots of nodes. We'll talk about that too. So if you don't understand that, that's okay. Different types, that's great, yeah. Types of panning, panning, yeah, we'll get into that. Offline, audio workers don't exist, great. Code. Oh, there's going to be so much code. So much code before lunch. I hope you're ready for that. See, lots. There's lots of code, code. Was this article helpful? Actually, it is helpful. MDM docs is very helpful. And then, of course, the other problem. No, there's some great examples. That's what I do next. Sorry, my next slide's not coming up. There are some really, really great examples of the audio API on the web. This is one of my favorites. This is called Blocklust. This is built by Luke Twyman, Luke Phillips, and Edward Silverton in Brighton. And I've got on my notes, it's well mental. It's a beautiful interface for a software synthesizer. So you can just go to this website and you can just play around with audio, and it's got these inputs and all these effects and these outputs, and you link them all together and you can create noises just with this interface. And this is heavily using the audio API. There's also examples such as this one. We've got audio, please. Is some audio? No? We did do a sound check, but this always happens. Thank you. This is Jake Albert's arpeggiator. It actually just runs in a code pen, which is fascinating anyway, considering all the functionality that it has. It just runs sequences of notes. But you can change those sequences, you can change the tempo, you can change the tones and the keys that they're in. It's got a heck of a lot of functionality for something as simple as just running a sequence of notes. It's really good. I recommend you go and play with it. And it's not these just sort of online things that you can just go to a browser and use. There's things like art installations that are using the Web Audio API. This is an installation called Piano, and it runs in a shop window, and it's an audio visualization. But it's also got a MIDI controller sat outside on the street, so that normal passers-by can come up and control the audio visualization with the MIDI controller, which is it's interactive and it's amazing. And this is all written in JavaScript. That's very cool. And there's not only that, there's been a series of this. This is a guy called Gregor Adams. You might be familiar with him. He built the Roland 808 to celebrate 808 followers on CodePen. It's the whole synthesizer in CodePen. And it's not just him. There's all these other synthesizers. Whew. I know. Where do we even begin with the audio API? I mean, all this stuff is proper engineering. Oh, I think it's even above my head. And then, of course, there's the other problem, is when you mention audio on websites, everybody sort of goes, oh, yeah. I know. Yeah. This is a real website, by the way, Cameron's World. It's one of my favorites. And just take that down a little notch. Yeah, you do that. You sort of think, yeah, that's what audio on websites is. You land on a page and audio starts playing at you and it's blasting at you, and that's an unpleasant experience, and we don't want to do that for anybody. And then the modern world equivalent of that is something like this. You're reading an article and you load the page, and then there's some freaking advert in the sidebar that just starts like talking to you.
So popular. We've been featuring local work at home.
No, we don't want to do that. I kind of want to readdress this, though, because there are some really, really good websites out there that are using audio in a really nice way. This one is Learning Music. Ableton built this. It's just a website, you can go to it, and sure, the subject matter is music, but it is harnessing the Web Audio API really, really well, and it teaches you all about sort of electronic music and how to use sequences and beats and patterns and everything like that. It's really, really lovely. It's really well thought out. Really, really clever website. There are some that actually do play music on load, but again, it's a really, really lovely experience. Bear with me. This is a really wonderful site. I'm just going to chuck the audio up so you can hear it. I don't know if it's going to be loud enough. It's not that intrusive. This is a site called Future Library. It was built in Norway, and it's about planting a tree for the next 100 years, one tree for the next 100 years, and they've got 100 authors to write a book for every tree that they plant. And there's sound all the way through the site, but it enhances the experience. There is a mute button. It's a mute button, so that when you do land on it and you do want to mute the audio, it's right there. It's not a horrible experience, and the sound is really lovely. It really enhances it. There is also this, 86.5 years. We all chill? I'm super chill. Yeah, it's nice, right? This is a story website. It's about the musings of an 86.5-year-old man. None of these sounds are horrible. We're playing music on load. This one is an especially good website, by the way. It's very, very clever. You actually change the chapters. It uses your webcam. You change the chapters by closing your eyes. Web APIs. Brilliant. One thing to note, and I sort of touched on it, there is mute functionality on the Forest site, really important, and I'll bring that up again later. There isn't one that's obvious in 86.5 years, but it does say on load its best experience with headphones, so you are aware that sound is being played. That is something very thoughtful and something that we should think about. So, audio API. Probably get in the nitty-gritty. Before I do that, I do want to, and is this slide going to work, talk about digital audio just for a little bit, just so we're all on the same page. I'm not going to go into it in massive detail. This isn't a talk about signal processing. It's very tricky to sort of get it at the right level because it's a tricky subject. Oh, yeah, we've got to think. I'm sure that you've all seen something like this. This is a sound wave, right? This is what we call a sine wave. It's a nice, pure wave. It sounds a little bit like this. Yep, apart from my little clicks at the beginning. There's no distortion in that. It's very, very pure. That's because we're creating this lovely curvy wave like this. On the x-axis, we have time. On the y-axis, we have amplitude. That's sort of volume, sort of. In reality, sounds aren't this pure. The voice that I'm speaking at you with now, it wouldn't look like a wave like this. It'd be all jaggedy and distorted. I know my voice is lovely, but in reality, a wave like that would be all jaggedy. What we do when we record it digitally is we take the amplitude value, so what's on the y-axis, at a given time. And we do that a lot, so that when we play it back, we can recreate that wave. Something like a good example is a 44.1 kilohertz track. And that is basically taking 44,100 samples, amplitude samples, per second. That's a whole bunch of numbers. And that's the nitty-gritty of digital audio, basically. It's a bunch of numbers. It's a little bit more complicated than that, but for the purposes of this talk, that's our digital audio lesson. Are we ready for code? Okay. All right, you ready? There's so much of this. Boom. Oh, my God. So much code. Let's begin. The first thing that we need before we can do anything with the audio API is our audio context. That's basically the API itself. We need one of these per application, and everything in it we get an endless supply. I'm creating one instance here. It's just my context. This is my context, new window.audio context. Think of it a bit like a recording studio. This is the analogy people use. Inside it, you've got instruments and sounds, and you can load in sounds, you can create sounds. There's lots of effects. You can pipe it through desks and put effects on it and change volumes, things like that. And then you can record it or send it to the speakers and do things like that. So we need some sounds. Right. Well, we can load some sounds in. Load sounds. More code. Oh, code. There's three main ways to do this with the audio API. You can grab it from the DOM itself. So if you've got a video and audio element within your HTML, you can just go and get the source from that. And that's a pretty simple way of doing it. You can stream it. So from your mic or your camera on your device, you can stream the audio from that. Or you can go and get it from a file. Now, this is a slightly more complicated, but probably the most powerful of all three. If you have a file sitting on your server, you can go and get that file. You take all that data, all the stuff that I was just saying, put it into memory, but then you have to decode it into the audio API itself. There's lots of different file formats when it comes to digital audio, and they've kind of compressed these numbers in layman's terms. And you have to make sure that you can read all those numbers in the audio API in the same way. So that's why we've got this decode audio data method going on there. And then that means that we've put it into a buffer, which is sort of like a container for all that data that we can use within the audio API itself. So there are three main ways of loading sounds. And if we use any of those, that means that we then have a source. But we only have that source. We haven't yet played that source. So we've only got it. We then need to play it. And to play it, we need to connect it to something that does play it. In this instance, we're namely just going to go with our speakers. So what we're doing is we're getting a source, and we're just connecting it to our speakers. And that's what that line at the top is doing. Our context destination by default is our speakers, and we have to connect that through. We have to do that. It doesn't happen automatically. And we also have to start the sound. So actually, to do something as simple as getting a sound and playing it, actually quite a few lines of code. But there are reasons for this, and you'll see as we go through the talk. So yeah, if we do that, I'll go and get a file. I'll load it in, I can play it, and we get something like that. See, that's super loud. And that's what that is doing. Oh, that's like the simplest example. It looks a little bit like this. And this is a concept that we can bring in now, which is our audio graph and our nodes. Now, this one looks really simple, and you think, why would you bother drawing a whole diagram just for two boxes? Well, actually, these things build up very quickly, which is why we do it. These boxes, these are our nodes. So we've got our source node. That was when we went and got the file. And we've got our destination node. That is when we put it to our speakers. Our speaker is our destination. And the reason that we draw diagrams like this and we think about our audio graph, which is what this is we tend to put a lot of nodes in between. And this builds up very quickly, and it's very good to sort of draw it out and just see where it's going. If you use Firefox and you built something with the audio API, you can actually inspect it with DevTools. It has an audio tab, and it will show you the audio graph that you've built up, which can be really, really handy, because sometimes you're not quite sure what you've connected to what and where and what's going on. So this is audio graph and nodes, a concept which is sort of I wanted to bring in so you understand it, because I'm going to talk about nodes quite a lot. I touched upon mute functionality. So when you're playing a sound, when you go to a website and you play a sound, you want to be able to mute it. That's pretty simple, but we have to create a node. So we're going to create a gain node. Gain controls volume. And you can set the value. So we create our node at the top there, create our node context, create gain. And then we can put that within our audio graph. So we can add it to our source, but we have to specify a value for that. I specified 0 because I want to mute it, but it can be any value. If you specify 1, it will stay at the same volume. 0.5 will be half a volume, etc., etc. And then we connect it through. So before, when we had just connecting to audio destination, now we want to connect our source to the gain node and then to the destination. Then we can start it. So we can have mute functionality. That's pretty cool. Play, mute, play, mute, play, mute. Yeah, you get the idea. Great. Sorry. It's kind of fun when you start to play with it. And then our audio graph looks something a little bit like this. We've just stuck a gain node in the middle. Cool. There are a couple of other ways to alter sounds with the audio API. These are simple. There's loads more. We'll get into some of them in a minute. These are some simpler ones. There's a compressor node. What compressing does is, the best way to explain this is you are a very clever thing, right? You can listen to very, very, very quiet sounds, and you make them louder for yourself so you can hear them. And you can listen to very, very, very loud sounds, and you'll make them quieter so you don't get shocked. This is what a compressor does. It kind of normalizes the sound. And there's one of those nodes, so you could stick that in. There's also a delay node. I could go into that in like loads of detail. I think we all know what delay will do. It delays the sound. You specify a time to do that. And this one here, I've specified 5 seconds. It will delay my sound starting by 5 seconds. A good thing to mention at this point is a library, Howler.js. It's a good all-round library to use on the audio API. I wrote a lot of code there just to do like one thing, really, which is to play a sound and mute it. This is pretty good. It abstracts all of that away from you. You write less code, and it does it for all the functionality of the audio API. It's a really, really good all-round library. It also supports Soundspriting, which is a concept to mention. It's a lot like image splicing, which I'm sure you would have come across. You have one big audio file with lots of little sounds in, and you play those sounds at certain times when you want to play the sounds, rather than loading lots and lots of little files. There are reasons why that may or may not be a good idea, probably beyond the scope of this talk, but it supports that anyway, if that's what you want to do. This technique is heavily used in things like gaming, so that's a good thing to bring up as well. HTML games and VR, they like sound. And they use sound splicing quite a lot, especially in HTML games. VR these both use another technique which I wanted to mention, which is spatialization. Sound spatialization is, I'm going to try and explain it, and I might need a volunteer. Ah, yes, Tab, if you just stand up, actually. So Tab is here, right? So he's my listener, and he's listening to me talk. I hope he's listening to me talk. He might have switched off. And imagine for a minute that I'm not actually speaking through my microphone, and the sound is not coming through the speakers, and he's actually directly listening to me, and I'm the sound source. He stays there. If I move over here, the sound has moved. That's spatialization. Brilliant. And we have that in 3D, and we have that in the audio API. So if I go over here, the sound has now moved over here. If I face this way, my sound is now directional over here. He can still hear it over here, but it's probably bouncing off that wall. We have all that functionality, which is amazing. If I was to somehow fly, right, my sound is going to go up, and Tab's still there. Thank you very much, Tab. That was very kind of you. Yeah, a round of applause for Tab. I hope that I explained that. We have all this functionality. We have it in one node, but it's extremely powerful. And it's the Panner node, aptly named Panner node. I know. And what you need to do is you need to set a listener and you need to set a source. But by doing that, you get all of that. You get to say where these things are, how, if they're traveling, and in which velocity that they're traveling, in which direction that they're facing. With the sound source, you get the actual extra functionality of it being a cone source. This is interesting. The best way to explain this is like lights. Lights can be spotlights, so they can have a cone, they can be directional, so can sound, or they can just be like a bulb which is omnidirectional and, like the sun is just giving out light all the time. It's the same with sound, and you get to specify all of that. This is a very, very simple example. I'm just setting up a listener and a source, and I'm kind of hoping this will still work. So imagine Tab was the red dot, I'm the blue dot, and I can move around. Ooh. Quite quiet on these speakers, isn't it? But I'm sort of going away from him. So it is getting quieter, and I'm going around him. And then I'm coming back, and I'm in front. Great. And I can go back. And so on and so forth. Good, I'm glad that worked on the slide. Great. That's the panner node. There is a stereo panner node, worth a mention. It's a very simplified version of that. It's sort of 1D, it's very static. It's just the idea that you can pan between left and right speakers. Might be easier to understand. That's spatialization, heavily used in 3D. So 3JS and A-Frame both use that technique in the audio within their 3D scapes. Phaser, also worth a mention. If you are building HTML games, any audio features that you want to use is included within this library. So you don't really need to instigate your own audio API. It's pretty powerful when it comes to the audio stuff, as well as, of course, all the gaming stuff that you would use Phaser for. It's there for building games. Great, so we've done we've got our sound, kind of moved it around. We've done some audio, we've done some volume. We can also make sounds. Right, this is where it all starts to get interesting. This is one way of making a sound. We can create an oscillator. So the sine wave that we showed before, this is what an oscillator is doing. It's creating that wave for you. There's a couple of different types of waves. So in this code here, I'm creating a triangle wave. Do I have triangle? Yes, I do. Slightly different from the sound that we heard earlier. You can also create your own wave shape, which is interesting. And that's what the create periodic wave method is doing here. So you can create your own wave. That's new functionality. That's cool. And then you attach that to your oscillator. So that's just generating a wave. The thing is, with something like that, cool, not very interesting, is it? Neither was the one before. By the way, the different types of oscillator by default are sine, triangle, sawtooth, and square. The reason for that is because they're easy to generate. If you do try and generate your own wave, you are going into the realms of long mathematical functions, which can be fun. I like it, but it might not be for everybody. There is a lot of built-in stuff with the audio API. One of the ones that I want to mention is this method, exponential ramp to value at time. I'll go through it. And you can kind of put this on quite a lot of stuff. The frequency that we have the oscillator running at. Frequency is sort of how high or low the sound is. We can put this method on that. And let's start with the value at time. What I'm doing is I'm changing the frequency at a time. The exponential ramp 2-bit, that just means I'm doing it with a curve. You can do a linear value at time, which will do it in a straight line. But I want to do an exponential ramp too, because a curve to the ear just sounds a lot nicer. And that's all that method is doing. So here, with those values, I'm lowering the frequency to 10 after a second. So I'm just doing that with a sweeping curve. And actually, on that oscillator, I want to put a gain node in my audio graph as well. And we all saw the gain node earlier, so we all understand that. But I'm going to put an exponential ramped frequency there. It's like the hardest thing to say. I'm going to put one of those on my gain node as well, so I'm going to drop off the volume after a second too. Because if we do that, laser, not even joking, this is where it starts to get fun. I know, right? That was the oscillator. Just by dropping the frequency down and just by dropping the volume down, just with those 2 lines of code, hat tip for my crew, by the way, that is my alternative to an air horn. So we can create sounds. There's another way we can create sounds. Remember we were talking about how an audio file is sort of just numbers? We can kind of generate those numbers, put them in a buffer, make some noise. This isn't a great example, by the way. This is definitely not my favorite. This for loop here is creating random numbers. And you can create random numbers and put them in a buffer. I'm sure there are a few of you out there thinking, oh, God, if you create random numbers, you're just going to get some white noise. Yeah, you are going to get some white noise. Are you ready? It's not very nice. Oh, I actually had to reduce the time that plays for because it's like, there's a nicer version of white noise. It's called pink noise. And there's a much longer equation that you write to generate pink noise. So instead of just generating random numbers, you kind of cap it a little bit so you don't get the kind of hissing at the top and the horrible stuff at the bottom. There are some other lovely things that we have with the audio API, which means that we don't need to write big, long equations. We can do things like pass that noise through a filter. There are more involved ways to alter sounds. It's kind of interesting. I feel like I'm kind of getting through most of the audio. I didn't think I would. These are other ways to alter sounds. These are more involved. I feel like this is more of the advanced stuff. We have a biquad filter. So this is your filter, and what this is doing is it's kind of filtering the frequencies, the high and low stuff. You can, here we've got a low pass. We've made it a low pass. There's lots and lots of different types. It's passing through the lower sounds, right? So I've got a value for that. So I've got 500. So anything below 500 hertz, it passes through. There's a high pass filter, so anything above a value that you specify, it'll pass that through. What I've done with the white noise is I've actually specified a band pass filter, and what that does is it caps off the top frequencies and the bottom frequencies, and it's passing through all the frequencies in the middle. And I can basically sort of fake pink noise by doing that, which sounds a little bit more like, that's a bit nicer. I like that. It's a lot less harsh. There's a couple of other ways that you can manipulate sound. There's the wave shaper node. Now, you have to create another wave for this as well. And what this does is when you put that on your source and you connect it to your source, it's multiplying the wave that you've created to the source. So that nice sine wave we have, if you create another wave, you multiply those two together and you get another crazy shaped wave. So that could be fun to play with. And there's also a convolver node, which is mostly used for reverb. But this, you add another sample to the wave that you have. So you load in another sound, and you add that to the sound that you have. It does mostly create sort of big chamber orchestra room effects or little basement flat effects and things like that. That's what you'd usually use it for. But these are the more kind of, you're getting into the geeky maths here. You can write a lot of equations when you're working with this stuff. So we've got some pink noise. Great pink noise. Yeah, that's all right. We do what we did before with the laser, where we kind of cut it down and we kind of make it fall off. Snare drum? Anyone? Yeah, could do that. Yeah. There's some stuff on the internet about how to create a snare drum, and it's a little bit more long-winded, and I was like, can't we just cut off the volume? Yeah. Yeah, we can. That totally works. Snare drum, great. Whew. Wow, we're actually on the last one. Oh, I didn't think I'd get through it. It's so good. So that's a lot. That's the bulk of the audio API. There is more stuff. Each of the things that you've seen has their own set of methods and properties and functions and all the rest of it. It's all in the docs, but that is most of the overview. There's one more really, really important thing. Timing. We're playing music. And it might not be just you want to play one track and you want another track to come in. You might have one sound and you want to match up another sound next to it. The timing has to be accurate. Your ear is extremely sensitive, and it's really, really good at knowing when things are not working. It's good at picking up glitches. It's good at picking up when these samples that we have drop off. It's good at noticing when drum patterns are out and not on the beat. We have this with our context, and it's current time. It starts when the context gets made right at the beginning of our code, but it's super accurate, and it's amazing, and it's a super big, long number as well. So it is in seconds, but because it's so accurate, it's really, really great. It's such a great piece of functionality. I think it's probably goes beyond the audio API. It's an amazing, amazing piece of timing. It uses the subsystem's hardware clock. So it's not like your normal JavaScript timing, which can be flaky to say the least. Say you wanted something like a drum pattern, so you wanted that snare that we had to hit, like maybe every half second. You might think, oh, I'll just create a set interval for that. Yeah, set interval half second. That's not going to hit every half second. You're going to have other things interfering with that set interval. Use this. Use this as your benchmark. Put a loop in. It will be a lot more accurate. I have loaded in a hi-hat rather than a snare, and I've used that method, and we get... That's just looping over, and that's just adding time to when I first made my context right at the beginning of the talk. That's pretty accurate, right? I didn't hear any, yeah. Really, really important bit. If you are starting to get into the realms of creating your sounds, you want to do the more synth-based stuff, you're thinking about sequencers, stuff like that, ToneJS is a great library to use for this. It harnesses that timing stuff amazingly well. It took me a while just to code that hi-hat, and I was thinking, why am I not just using Tone for this? It was what Ableton used for their learning music site, and it's one of my favorite libraries, actually. It's really, really good. Whew. Fist bump, ladies and gentlemen and others. Yo, Audio API. I did that in like 25 minutes. That's really, really good because now we get on to my favorite subject, MIDI. Okay. I'm kind of glad that I actually got to talk about audio before I started talking about MIDI, because there is a common misconception when it comes to MIDI. And it goes a little something like this, which we saw before. This is not MIDI. We know, actually, because we just made a lot of sounds, that they're obviously audio. We made them with the audio API. The common misconception, I think, comes from the fact that MIDI does stand for Musical Instrument Digital Interface. But MIDI itself is not actual any audio. It is just the data that is being passed from musical instruments. It's controlling the audio. And that's what it's there for. It came around in 1983, the first spec was published. There was a rise of electronic instruments in the 1970s, and the popularity increased to the point where music industry manufacturers and experts sort of thought, this is great, we've got all these instruments sending electronic data, but they can't talk to each other. They can't talk to the equipment in the recording studios. Maybe if we had one protocol so they could all do that, then they could, and they could all talk to each other. And that's when they wrote General MIDI 1. And it has been around ever since. The spec has moved on a little bit from that. There is now General MIDI 2, but General MIDI 1 is still about. Other specs have come from MIDI. So MIDI came out with a show control spec at some point, which was the idea that there was a lot of instruments being played on stage. And all the equipment people were thinking, well, actually, if you're sending data, can we send data to, like, lights? Can we send it to pyrotechnics? And so they brought a show control spec out to do that, so they could actually control lights and things. DMX, which is now what they use to control lights, is heavily based off MIDI. There's loads more specs these days. There's things like a Bluetooth low-energy spec for MIDI. There's a polyphonic spec, which is when you're just playing a keyboard, you don't just press the notes anymore. You run your fingers up and down, and it's all touch-sensitive. So it's super interesting stuff, MIDI, actually, if you want to get geeky about it. Did I just get super geeky about MIDI? If you want to find out more, they have just redone the website, and all the specs are up there. So you can go and read more about it. This is a MIDI instrument. This is something to take note of. I'm pretty sure you've all seen one of these. This is a keyboard. You sit and you play your keyboard. I can plug this into USB into my computer, and it will send my computer MIDI data. The difference between something like this and this, which I will get back to in a minute, my slides are running really, really slowly, is this has onboard audio. So you can play this standalone. So this, you can just play it, and it's fine. This is a MIDI controller. So this doesn't have any onboard audio, but when you press the buttons, it still sends MIDI data. So I can plug this in via USB. USB is more commonly found these days. It does make everything cheaper. Back when it first came out, we used to have big round DIN cables, and you used to need a specific sound card for it. So this, you plug into your computer, and it sends MIDI data. There are a lot of these type of things. If you want to get started with MIDI and you don't have an instrument at home, I would suggest one of these because they can be quite affordable. There's lots of them. You just need to search MIDI Controller and it would just come up with a whole array of amazing things. This one in the bottom here, this is mine. It's called a Minim. I've got it here, hoping it doesn't disconnect. It actually runs over Bluetooth, so I don't actually have to plug this in to my computer, which is nice. It's really handy to carry around. It's my handbag MIDI controller. It's light, it's small, it's great, Bluetooth. Sort of affordable. If we run this code in a browser, I can pick up on the MIDI data it's sending. It's pretty simple. You just request MIDI access on the navigator object, returns a promise. On success, I can log the value that this MIDI controller is sending. I've got a code pen here, and I'm just wondering, I'm hoping that my MIDI controller hasn't lost connection with the browser, because that does tend to happen. Okay, cool. So if I, yeah, that's coming up. If I press the buttons on my MIDI controller here, I've got a nice little sort of slider here, which is super cool. And it's just logging the data. And you can actually, this code pen works with any MIDI controller. Well, it should do. So if you do have one at home, just plug it in, run this pen, and you can see the numbers that it brings up. This is really hard. Did anybody notice there for a second what we were actually doing? Just shut that down. Move that. Hello. Okay. We've got lots of sounds, and I can play those sounds when I press buttons on my MIDI controller, which is sort of the idea. This is like a little mini sound box. This may or may not work. Should we see if it does? Yeah. Okay, cool. Hopefully, when I... Oh, I love that kick. Get one of these, they're cool. Oh, amazing. Wow. I'm running early. We're all running early. We get to go to lunch early. This is great. Quick review. Audio API, there's loads and loads to it, and I have only sort of just briefly covered it. Loading sounds important. Buffers, if you can get that concept, they are really, really powerful, and they're great to play with, so get into that. Audio graph and nodes. Nodes is an important concept to understand because you are fitting things together all the time. You're creating them, and you're connecting them through, and you're connecting them to other nodes, etc., etc. Creating and modifying sounds. Modifying sounds can get super geeky if you want it to. You keep it simple, you can make it really, really geeky. Timing is important. It is important. Get used to the current time because it's so powerful. For such a small, tiny thing, it is really, really powerful. And MIDI is super cool. I do understand that some of the demos that I have shown to you today are not necessarily ones that you are going to build into a website. Although, could please somebody just make a website with a laser button in the middle? I feel like that would be, I'd be into that. But I do also hope that some of these techniques that I've covered will get you started, because I think there's a barrier to entry with audio, especially considering how technical it can get. And I also really want people to start thinking about sound design and web design because of this idea that people shun away from it because you don't want to have horrible audio playing when you land on a website. Of course you don't. We get really, really excited about all the wonderful things which we're going to hear about over these 2 days. Animations are amazing. Grid system is super fun, and it's going to solve all of our problems. But VR, I'm super excited by Ada's talk. It's coming off after lunch. But when it comes to sound, everybody's like, ugh. Can we be a bit more excited by sound now, please? We're clever enough to make this a beautiful experience for people. And it can be simple as adding accessibility to forms or having a beautiful sound on a beautiful animation on a hover. That's it. Or we can just make it part of the overall experience of the whole site. We have lots of apps, obviously, and games and things like that, and it all falls into that as well. But please, please, this is preachy end of talk right here. Go away. Think about sound in your web design. Be cool. Make noise. Good noise. Thank you very much.
Come join me.
Hello. Oh, do I have to go say, it's leaving my laptop. It's so weird.
Okay. You can stay over there if you like.
Let's go, bring my tea.
Maybe you can play some background music or do some tunes for us. How is it that the web audio API is so advanced and complete while form validation doesn't work?
Because Chris Wilson's a genius. I don't know. That is a really good question. I think probably because if you are into this, you are into this and you know all about it. Whereas form validation is something that we have just been building up and building up and building up since the web started. This has been around for 50 years. Sound's been, in the modern day stance.
Yeah,
So
I
it's
suppose that
already,
makes
it's
sense.
already there, isn't it? And we're just making it into web.
And speaking of that, there's a lot of jargon, like very specific words that you're supposed to know the meaning of, like oscillators and things like that.
Yes.
It all sounds very fancy. Is there a good resource that you could recommend if you want to find out more about all this?
Wikipedia. I actually have been thinking about this. I think there's almost a call just for an article for like just the language for web developers and just a simple thing. Just simple things like sample. What's the sample? What's sample rate? What's bit rate when it comes to actual audio files? And we're all aware of what bits are, but what is that? And I think I've been talking to a few people really, and I think they understand how an API works, and they're ready to get ready with the code, but there's this sort of gap of going from that leap, and they need that knowledge in the middle. So I think there's a call for that resource.
You gave a lot of examples of producing audio and then modifying it as well, but I thought the audio API was about analyzing audio data.
You can analyze data as well. This is the kind of one we have there. I could show you an example of analyzing. I did leave that out of the talk, which I do apologize for. There is an analyzer node, so you can pipe it, you can get your source, and you can take your audio, and then you can analyze it. And this gives you back data on the actual amplitude of the sound that's coming through. It's really amazing, and you can create amazing visuals. I did a talk about this, so you can find that talk, and it's purely just on the analyzer stuff, which is kind of why I left it out of this talk, really, because there is resources out there just for that node.
There were lots of questions on Twitter as well, by the way. One person is wondering, is the Doppler effect possible to achieve using the Web Audio API because it knows about distance and direction?
Yes, so with the spatialization stuff, with that panel node, you can create a Doppler effect because the velocity of the listener can be going towards the velocity of the sound, yeah, or away. You can create the Doppler effect, yes.
You've done this before, haven't you?
I haven't done it. I just read a lot about it before I came. Kind of want to do it. We should do it. Should make that happen.
Another question is, what's up and coming for Audio API?
Worklets are in the pipeline. So this is taking some of the processing away from the main thread, like web workers, but for audio. What else is up and coming? There's something else I was going to mention. Oh, it's completely escaped my brain.
That's all right.
Let me Google that for you.
Yeah. Yeah, is it possible to build a website and add some audio as an enhancement to it? Because you've given a lot of examples where audio is really part of the experience, but they're kind of interactive websites. For a more static website with just textual content, are there use cases, you think, for the
Yes,
Web
I
Audio
definitely
API?
think there's use cases. Like I mentioned at the end there, something like form validation. I think you have to be very careful about being intrusive, but we're very quick to put red borders on like form fields that haven't validated. But maybe some audio feedback to say, I've kind of been thinking about this for a while, but I can't think of a good way to do it, to say, yes, you validated, or no, it's not validated.
Maybe
Things
some
like,
pink noise?
yeah, maybe some pink noise. I don't think that would work with the make nice noises thing. Button hovers, literal animations like that, I think definitely interface noises.
Another question was, do the spatialization properties recreate the binaural audio effect? And I think we can start by explaining what the binaural audio effect is.
Binaural audio effect?
It's, yeah, I've heard of this before. It's when you listen to an audio file with headphones, and it really sounds like it's happening in the same room. Like you hear someone knocking on some wood, and it's like, oh, there's someone by the door.
That's basically what it's for. Yeah, because and I think a really good example of this is VR. Is sort of when something's creeping up behind you, and creeping sort of that whole creepiness of it all. Yeah, because you can, I guess, assume you'd have to make an assumption of the type of room that you're in, but then you could use the convolver node to create that room effect and add that onto the spatialization.
Right. It's deep stuff, food for thought. Here's another random thought from someone on Twitter. If DMX is heavily influenced by MIDI, does that mean there's a web API for it?
No, there isn't a web API. Talk to Martin, who's part of the Live.js crew. He has created a whole piece of software where he uses DMX to control lighting with JavaScript. So he would have 100% the answer to that, plus a whole GitHub repo of code. I will tweet the person who said that with his Twitter.
Right, yeah, I think you have some tweets to go through after this. There's a lot of feedback and questions on Twitter.
Okay.
Have you heard of anyone writing a guitar effect on using the Web Audio API?
Yeah, there's a few pedal effects out there, I think. Yeah. I'm trying to think some off the top of my head, but it's some of those things that you just come to and you're like, that's cool, and then you carry on browsing.
Right. Would it be possible to use the Web Audio API with like Arduino devices if you hook up some soundboards?
Yes, because you can use onboard JavaScript, can't you? There's like a JavaScript library, although I don't know whether you could actually onboard Web Audio. The picture that I had at the top of the talk with me with the audio reactive LED strings, I was using an Esprit board, which has exactly the same functionality as an Arduino, but it's onboard JavaScript rather than C, so it's much nicer to program with. I highly recommend those, and I was using the audio API to do that with. So if you want to do that, I would recommend an Esprit board if you want to do any hardware stuff.
So there's nothing stopping you from creating your own hardware guitar pedals, if that's what you want to do?
No.
That's pretty cool.
Oh my goodness. No, I've been thinking about controllers for a while, because there's nothing stopping you doing that. Like what I have up there,
okay.
But like a custom one, because it's hard to find exactly the functionality that you need at the price that you want it, even though there's a million MIDI controllers out there.
Another use case that I've seen with these launch pads that you have is that if you're using it to make audio, like you can set the BPM, and then you can make sure that when you press the button a little bit too early, it kind of auto-corrects.
Yes. So Matt, also part of the crew, I'm so glad they're there. You give me so much information. He wrote a whole piece of software called Loop, where he sets up samples and he plays them on his launch pads, and he uses that technique just to make sure that if he doesn't necessarily hit it at exactly the right time, it will actually still come up at exactly the right time when he's actually playing.
Yeah, that sounds pretty cool.
Yeah.
Thank you for your talk. This was amazing. Lots of live demos.
Thank you,
so please give her a warm hand.
Thank you.